The Excel demonstration today is about the idea of at least probability. So I'm using the Excel workbook called Excel Demonstration At Least Probability. What we want to talk about today, and I put a lot of explanation on here, but we're going to talk about it and then we're going to use the Excel commands. So the first thing that I put up at the top is just the idea that it's going to be easier to compute at least one probabilities if you understand the one concept. And that one concept is the fact that at least one is the complement of none. So if you can compute the probability of none, then we're just going to use 1 minus, and so we'll subtract that value from 1 and we're going to get the answer. So in the general idea, the first thing that we want to do is we want to identify our probabilities. And then the question, as far as the story problem is concerned, is going to say, what's the probability that at least 1 is, and then whatever the story problem pertains to. So in general, you're going to be given a problem statement and you're going to be given one of the probabilities and you're going to be able to know both of them and give them their labels. So P is the probability. That's the probability of success. And Q is the is not probability. That's the probability of failure. And when you add them together, the P plus Q, you should get 1. The general formula for this particular type of question is the probability of at least 1 is 1 minus the probability of not raised to that power. And so that's the equation that's behind this idea of the binomial. And so we'll do this one by hand using the equation, and then we'll use the binomial function on Excel. Let's look at that for a minute. So the idea that Q to the n term is the probability that all are not. Because remember, Q is the not probability. So that's exactly the same thing as saying none are. Remember that none is the complement of at least 1. So 1 minus Q to that nth power is the probability that at least 1 is. So let's walk through an example. So our example says approximately 10.3% of American high school students drop out of school before graduation. I'm going to randomly choose 10 students entering high school, and I want to find the probability that at least 1 drops out. So the is probability, our success, is 0.103, the idea of does drop out. The is not probability, the probability of failure, is 0.897, does not drop out. And remember, the sum of those two should equal 1. N is the total number of students, so those are my 10 students that I randomly selected that entered high school. So the probability that at least 1 drops out is 1 minus the probability of not, the 0.897 raised to the 10th power, which is 0.663. Note, I put in parentheses that the probability that none drop out is 0.897 raised to the 10th power, or 0.337. So remember, our rounding rules when we're working with probabilities is we're rounding to 3. So now let's use our Excel function. And so let's do exactly these same calculations, but I'm going to use the Excel binomial function. So the probability that none drop out, I'm going to type in, so equals binomial distribution, parenthesis, and then it says the number, so the number that goes behind it, so the number of successes. So I'm going to say 0. 10, and then the probability of dropout is 0.103. So the probability of 0 out of 10 not dropping out, and it's okay to just say true because cumulative, it's just going to add 0. It's just that single point anyway, so we'll just put in true. So in this one's case, it wouldn't matter if we put true or false. When I push enter, 0.337229. So that's the same as the probability that we got right up here the 0.337, so rounded to 2 decimal places, that's what we'll say, 0.337. Then let's look at, so I'm going to take this and I'm going to take my decimal and I'm going to drop it down so that it goes the right way. So it says exactly what we want to the 3 decimal places. And so the probability of at least one dropping out is going to be 1 minus. So I'm going to take this and I'm going to say equal 1 minus, and I'm going to use this one up here. So 0.663. So exactly the same as we got up above when I was using the formula 1 minus 0.897 raised to the 10th power. So let's try this idea again, but this time I wanted to try some that are similar to the ones that we have in our textbook. And so in our textbook, we have, other things besides at least one. So I'm going to go through this example 2 more times, and the first time we're going to say at least 3 students drop out. And so I typed this up so that you could see what it meant by the idea of at least 3 students dropping out. So the probability of that is the probability that 3 drop out, 4 drop out, 5 drop out, and I'd have to take that binomial and I'd have to calculate that for all of those, 3, 4, 5, 6, 7, 8, 9, and 10, and then I'd have to add all of those together. So I forgot the number 7, so let me type that in here. So probability of 7. And I'd have to do that binomial calculation. I'd have to use that Excel command, and I'd have to use it all of those times, and I'd have to sum them up to get that probability. So what I put right below that is so I can either do the binomial 3, 4, 5, 6, 7, 8, 9, and 10 times, or down below I said I can look at it as the probability of 1 minus x is less than 3. So the first one is the probability, so at least 3 drop out, is x is greater than or equal to 3 because of the word at least. In the second equation that I put here, I said 1 minus the probability that x is less than 3. So I would say 1 minus the probability of 0, the probability of 1, or the probability of 2 dropping out. And so I could do that binomial the 3 times, add those together, and subtract them by 1. Subtract them from 1. But the nice thing about this binomial distribution is, remember, we can use the idea of it accumulating. And so if I put the word true in, it's going to accumulate the binomial for 0, 1, and 2. So it's going to do a cumulative idea as far as the binomial is concerned. So I wanted you to see, so over to the side in this spreadsheet, I went through and I did all of the probabilities from 0 all the way to 10. And so this is the probability that none drop out. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so that's the point distribution for the binomial for each one of those probabilities. And so that would be that entire table with all of the possibilities of that discrete variable going from 0 to 10. So if I was looking at that top one of at least 3 dropping out, I could sum from this table 3, 4, 5, 6, 7, 8, 9, and 10. Or if I'm using this binomial distribution function in Excel, down here I'm going to say 1 minus the binomial distribution. The number of successes is 2 out of 10, with the probability of success being 0.103. And I'm going to say true because it's going to do cumulative. So look over here in bold, it says cumulative. So I'll put the word true, and that means it's going to do the cumulative value of 0, 1, and 2. And then when I push enter, I'm going to get 0.075451 rounded to the right decimal places. So let's see. So we'll come over here and we'll round that to our 3 decimal points, 0.075. So that's going to be the probability that at least 3 students drop out. The last one that you're going to run into, so a lot of times when these problems have part A, part B, part C, one of them uses the idea of the complement, and in one of these problems it says, what's the probability that at least 6 students graduate? So if I say at least 6 students graduate, the probability of them dropping out is 0.103, and the probability of them graduating is 0.897. So the probability, so it says, what's the probability that at least 6 students graduate? So I would take the probability of 6 graduating, 7 graduating, 8 graduating, 9 graduating, and 10 graduating. So I could do the binomial distribution and just do the point distribution for those 5 numbers and add them together, and that would be the probability of at least 6 graduating. Or I can use the complement in this case so that I can use that cumulative idea with the binomial so that I can use that word true. And so in the second one, I can say the probability of at least 6 graduating is 1 minus the probability that none graduated, 1 graduated, 2 graduated, 3, 4, and 5. So again, I randomly didn't put the probability of 2, so I'm going to put that in there. So I'm going to correct this. Then when I do the binomial and I put true in when I type that function, I can use that cumulative, and down here we're going to say equals 1 minus binomial distribution, oops, dot distribution, and we'll put 5 out of the 10, so 5 successes, and my probability is 0.897, and we'll say true because then that means I'm going to do the cumulative 0, 1, 2, 3, 4, and 5. And then when I push enter, I get 0.99813. And then let's fix those decimal places again so that we're rounding them right. So 0.998 would be my answer for that last part of the question. So I wanted to take some time to go through a couple of these, one using the formula, just showing you how that would work, 2 of them going back and talking about the binomial distribution and using the idea of the cumulative by putting true as that logic statement in the binomial distribution.